Hello friends, how are you? I am here to discuss atomic radius of an atom. How we will determine mathematically atomic radius of an atom. I will prove this equation. Firstly, what is atomic radius? Atomic radius is the atomic is derived from atom. So atom, radius of atom is called atomic radius. What is atomic radius explanation with respect to with diagram? This is atom. This is a nucleus in which proton and neutron are present. Proton have positive charge, so that's why nucleus carries positive charge. Electron are present in valence shell. Like we can say that this is the structure of hydrogen. Hydrogen structure, because hydrogen have one proton and one electron. One electron come in this shell, S shell. Yeah, we can say that. Sorry, K shell. If I talk in subshell, this is S subshell. So distance from the nucleus and electron which are present in valence shell. This is the radius. This is the atomic radius. So this distance I will determine by mathematically equation. So next, when an electron move in the circular path in his shell, two forces act upon it. One is the electric force. We can say that that is electric force, because here positive charge, here negative charge, here force of attraction is present. We can say that that is electric force. And other force is centripetal force. Centripetal force is that force which compel the electron, this electron, which compel the electron to move in the circular path. Circular path, this is circular path. So one is the force, we can say that that is electric force, which is equal to Z square over 4 pi epsilon naught R square, and another force is centripetal force. This is equal to M square over R. That is centripetal force. Both forces are equal, so we will compare. 4 pi epsilon naught R square is equal to M square over R. Here R cancel out. Uh, Here R cancel out. This M will transfer here. So V square is equal to Z E square over 4 pi epsilon naught R M. This is the first equation we got from comparing both forces. Next is angular momentum. According to Bohr atomic model, angular momentum mvr is equal to nh over 2 pi. 2 pi is a constant, pi is a constant value, n is the number of shells. This is the n is equal to 1, and here upward that is n is equal to 2. So h is the Planck's constant, m is the mass, v is the velocity, or is the radius. So here v square, this m and r will transfer here in that side. R is equal to nh over 2 pi rm. Sorry, v. Here scaling on both sides. Okay. So v square will n square is equal to n square over n square s square over 4 pi square r square and m square. So this is the second equation. No, here v square and here also present v square. So both equation will compare like this: z square over 4 pi epsilon naught or m is equal to n square s square over 4 pi square r square and m square. Here I will remove it. So here same factor are present in both sides, so it will be cancel out. 4 pi square, 4 cancel out, pi cancel out. Here rm cancel out. Z square over epsilon naught is equal to n square s square over here pi r m will remain. We will determine radius of atom. So radius, other factor will so firstly we will cross multiply like this: n square s square epsilon naught, okay, and other factor will here z square r z square pi m r. So this factor like this: r is n square over z. This factor, this is the constant value. Let this is constant value is n square over z 0.059 something, okay. So I consider that this constant value is that, okay. So this is the equation to determine the radius. Let's firstly this structure, this is the electron. So here first n is equal to 1 because this is the first shell. So we will determine, so we want to determine radius from here to here, distance from here nucleus to electron, that is atomic radius. So we will determine. This is the structure of hydrogen, and hydrogen atomic number is 1. One electron and one proton is present in the hydrogen structure. So here next r is equal to, and we want determine first shell atomic radius. So here n is equal to 1. So putting the value 1 over z. Z is the atomic number. It is donate the atomic number of atom. So hydrogen atomic number, we know that is 1. So 1. This is a constant value. So this is a composed value. This is composed value of radius from it. If we determine this is n is equal to 2, n is equal to 1. So we will determine distance from nucleus to second shell. So we will put the value. Second element is helium. Helium atomic number, we know that is 2. So r is equal to here n. We will determine the second shell atomic radius. So here 2 square over 2, 0.059 nanometer. So 4 by 2, 2 and 2. So something value will appear here. So this is the radius for second shell. This is composed value. So this is this equation through which we can determine the atomic radius of any atom. This is the number of shell from which we determine the distance, we determine the radius from nucleus, and here that is atomic number of specific atom. Okay, best of luck. That was lecture. Next will be